In this demonstration, we will configure and manage services using systemctl commands to start, stop, enable, disable, and check the status of services in Red Hat Enterprise Linux. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. Let's first check the current status of the SSHD service. In the terminal, type the following command: systemctl status SSHD. Then press Enter. This command displays the current status of the SSHD service. In the output, you should see active, running, meaning the service is currently running; enabled, which means it starts automatically at boot. Once verified, clear the terminal screen. To start a service, we use the start command. In the terminal, type systemctl start SSHD. Here, SSHD is the name of the service. Press Enter. This command starts the SSHD service. To stop a service, type systemctl stop SSHD. Press Enter. To verify whether the service has stopped, type systemctl status SSHD. Then press Enter. In the output, you will see that the service is inactive, confirming that SSHD has been stopped. Now clear the terminal for a fresh view. To restart a service, type the following command: systemctl restart SSHD. Then press Enter. This command will restart the SSHD service. To verify whether the service has restarted successfully, type systemctl status SSHD. Then press Enter. In the output, you'll see the status of the service, which should show active, running. This confirms the service has restarted properly. Let's clear the terminal again. To check if a service is enabled to start at boot, type the following command: systemctl is -enabled SSHD. Then press Enter. If the output shows enabled, it means the service is set to start automatically during the boot process. To manually enable the service at boot, type systemctl enable SSHD. Then press Enter. This command will configure the service to launch automatically at startup. To disable a running service and prevent it from starting at boot, type systemctl disable SSHD. Then press Enter. The output displays a message indicating that the service has been removed from the startup process. Now clear the terminal for a fresh view. To check all the active services on your system, type the following command in the terminal: systemctl list-unit --type equals service. In this command, list-unit lists all current systemd units. --type equals service filters the list to show only services. Then press Enter. In the output, you'll see a list of services that are currently active or loaded in the system. To exit the list, press Ctrl+C. Clear the terminal for a fresh view. To check for failed services on the system, type the following command: systemctl --failed. Then press Enter. The output will display a list of all services that have failed to start or run properly. For example, you might see entries like vbox add-service.service failed and vbox add.service failed. These messages indicate that VirtualBox-related services encountered issues during system startup or operation and are currently in a failed state. This command is useful for troubleshooting service-related problems on your system. Finally, clear the terminal screen. And that concludes our demonstration on configuring and managing services using systemctl commands to start, stop, enable, disable, and check the status of services in Red Hat Enterprise Linux. In this demonstration, we will manage service dependencies using systemd in Red Hat Enterprise Linux. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. To understand how services are interconnected through dependencies and how systemd controls these services, let's start by viewing the dependency tree of a specific service. In the terminal, type the following command: systemctl list-dependencies httpd. Here, systemctl is the command used to interact with system services. List-dependencies displays all the services and units that the specified service depends on. HTTPD refers to the Apache Web Server Service. Then, press Enter. In the output, you'll see a tree structure representing the HTTPD service and all its required services and targets. You can use the arrow keys to scroll and explore the list of dependencies. When done, press Ctrl-C to exit the view. Clear the terminal for a fresh view. Now let's view the reverse dependency list, that is, the list of services or targets that depend on HTTPD service. To do this, type the following command in the terminal: systemctl list-dependencies --reverse HTTPD. Then press Enter. In the output, you'll notice that HTTPD is required by higher-level targets, such as multi-user.target and graphical.target. This means HTTPD is an essential component for these system states. Now clear the terminal for a fresh view. To view the services required by the multi-user target, type the following command: systemctl list-dependencies multi-user.target. Then press Enter. In the output, you'll see a list of services that are started when the system reaches the multi-user run level. These services are typically used by multiple users. Examples include httpd.service, firewalld.service, cronid.service, sshd.service. These are essential background services available to all users on the system. To exit the view, press Ctrl-C. Let's clear the terminal for a fresh view. To view the detailed service unit file for a service like HTTPD, type the following command: systemctl cat httpd. In this command, cat is used to display the content of the HTTPD service file. Then press Enter. The output displays the complete unit file for the HTTPD service. You can use the arrow keys to scroll and explore the contents. Once you're done, press Ctrl-C to exit the view. Now clear the terminal for a fresh view. To view the current run level and the default system target, type the following command: systemctl get-default. Then press Enter. In the output, you'll see something like graphical.target, indicating that the system is currently running in the graphical mode, which is also the default target for the system. To further understand the concept of targets in systemd, you can check the current run level by typing run level. Then press Enter. In the output, you'll see something like N5. Here, 5 corresponds to the graphical.target, and N means no previous run level was recorded since the last boot. Finally, clear the terminal screen. And that concludes our demonstration on managing service dependencies using systemd in Red Hat Enterprise Linux. In this demonstration, we'll mask and unmask services in Red Hat Enterprise Linux. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. Now to mask a service, we use the mask command with systemctl. In the terminal, type the following command: sudo systemctl mask bluetooth.service. Here, bluetooth.service is the name of the service we want to mask. Press Enter. In the output, you'll see a symbolic link has been created that redirects the service to /dev/null. This means the Bluetooth service is now masked, and it won't start automatically or manually until it is unmasked. Now, let's try to start the masked service. Type systemctl start bluetooth.service. Then press Enter. As expected, you'll see a message saying, "Failed to start bluetooth.service. Unit bluetooth.service is masked." This confirms that the service has been masked successfully and cannot be started until it is unmasked. To check whether a service is masked, type the following command: systemctl is -enabled bluetooth.service. Then press Enter. In the output, you will see the status of the service. If it shows masked, that means the service is completely disabled and won't start, even manually. Now clear the terminal for a fresh view. Now, let's unmask a service. In the terminal, type the following command: sudo systemctl unmask bluetooth.service. Here, bluetooth.service is the name of the service we want to unmask. Press Enter. In the output, you'll see that the Bluetooth.service has been removed from the mask state. To check if the service is enabled, type systemctl is -enabled Bluetooth.service. Press Enter. The output will show that it is now enabled. To start the service, type systemctl start Bluetooth.service. Press Enter. This command starts the Bluetooth.service. To check the status of the service, type systemctl status Bluetooth.service. Press Enter. In the output, you'll see the current status, that is, it's active and enabled. Press Ctrl-C to exit the status view. Finally, clear the terminal screen. And that concludes our demonstration on masking and unmasking services in Red Hat Enterprise Linux. In this demonstration, we will use systemctl to reload and restart services and identify which services support reload. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's start a service. Type the following command to start the firewall-d service. Systemctl start firewall-d. Press Enter. This command starts the firewall-d service. Next, type this command to enable the service to start automatically on boot. Systemctl enable firewall-d. Press Enter. The firewall-d service is now enabled. Now let's check the status of the service. Systemctl status firewall-d. Press Enter. In the output, you should see that the service is active, running, and enabled. Clear the terminal for a fresh view. To stop the firewall-d service, type the following command. Systemctl stop firewall-d. Then press Enter. The firewall-d service is now stopped. To verify its status, type systemctl status firewall-d. Press Enter. In the output, you'll see that the service is inactive. To restart the firewall, type systemctl restart firewall-d. Press Enter. This command automatically restarts the firewall-d service. Clear the terminal screen. To check the status again, type systemctl status firewall-d. Press Enter. You'll now see that the firewall is active and running. Now clear the terminal again for a fresh view. To apply a new firewall configuration without stopping the service, type the following command. Systemctl reload firewall-d. Then press Enter. This command reloads the firewall rules and applies the new configuration without interrupting the running service. Clear the terminal screen. To check whether a service supports the reload operation, use the following command. Systemctl show-p can reload firewall-d. Here's what this command does. Show displays detailed properties of the service. -p can reload filters the output to show only the can reload property. Now press Enter. In the output, you'll see can reload equals yes. This means the firewall-d service can be reloaded without a full restart. Let's try the same check for the SSHD service. Type systemctl show-p can reload SSHD. Press Enter again. In the output, you'll also see can reload equals yes, which confirms that SSHD also supports reloading. And that concludes our demonstration on using systemctl to reload and restart services and identify which services support reload. In this demonstration, we will explore systemd timer units and create a time-based automation in Red Hat Enterprise Linux. Systemd timer units serve as a modern alternative to cron jobs, offering more flexibility and integration with systemd service management. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's create a simple systemd service script that will be triggered by the timer. In the terminal, type the following command. Cat, insert a here document operator denoted by 2 less than signs. Then type capital EOF, which stand for end of file. Then insert a pipe operator. Then type sudo /etc/systemd/system/cleanup.service. This command uses a here document to pass multiple lines of text directly into the T command. With sudo, T writes the content to /etc/systemd/system/cleanup.service, allowing you to create or update a systemd service file directly from the terminal with the required permissions. Now press enter. Now enter the following service configuration line by line. Unit inside square brackets. Go to next line by pressing enter. Description equals clear temp file with capital C, T, and F. Press enter. Service inside square brackets. Next, press enter. Type equals one shot with no space. In the next line, type exec start with a capital E and S, no spaces, then type equals /usr/bin/rm-rf/tmp. Then type /test file. Make sure there's no space in test file. And finally type capital EOF. Then press enter. Here's what each section does. Unit defines the service unit. Description equals clear temp file provides a brief summary of the service. Service section specifies how the service behaves. Type equals one shot means it runs once and exits. Exec start equals /usr/bin/rm-rf/tmp/test file specifies the actual command to be executed. In this case, it removes the file /tmp/test file if it exists. After you finish and press enter, the service file cleanup.service will be saved to /etc/systemd/system. Now clear the terminal for a fresh view. Now let's create a systemd timer unit to run a task automatically at fixed intervals. We'll start by creating the timer file. In the terminal, type the following command. Cat, insert a here document operator denoted by two less than signs. Then type capital EOF, insert a pipe operator, then type sudo TEE/etc/systemd/system/cleanup.timer. Then press enter. Now type the following lines, one by one. Unit inside square brackets. Press enter to go to next line. Description equals cleanup every 1 minute. Press enter. Timer inside square brackets. In the next line type, on boot SEC with capital O, B, and S, no spaces, followed by equals 2 minutes. Go to next line and type, on unit active SEC with capital O, UA, and S, no spaces, followed by equals 1 minute. Press enter. Type install inside square brackets. Finally type wanted by with capital W and B, no space, followed by equals timers.target. Here's what each section does. Unit section describes what the timer is for. Description equals cleanup every 1 minute provides a brief explanation. Timer defines when the timer starts. On boot SEC equals 2 minutes sets it to start 2 minutes after the system boots. On unit active SEC equals 1 minute repeats the task every 1 minute. Install section ensures the timer is enabled with the timers.target. Once all lines are entered, type EOF and press enter to save and exit the input. You have now successfully created the cleanup.timer file at /etc/systemd/system. Let's clear the terminal for a fresh view. Now let's reload systemd so it recognizes the new service and timer we just created. In the terminal, type systemctl daemon-re-exec. This command tells systemd to re-execute itself, which is useful after major configuration changes. Press enter. Next, let's enable and start the timer. Type the following command. systemctl enable --now cleanup.timer. Then press enter. This command enables the timer so it runs at boot and also starts it immediately. In the output, you'll see confirmation that cleanup.timer has been enabled and started. Now to check the status of all active timers, type systemctl list-timers. Press enter. In the output, you'll see a list of all currently active timers on the system. For example, you may see cleanup.timer which started 20 seconds ago. This confirms that the timer is working as expected. To exit the timer list view, press Ctrl-C. You've now successfully enabled and verified a systemd timer unit. And that concludes our demonstration on exploring systemd timer units and creating time-based automation in Red Hat Enterprise Linux. In this demonstration, we will configure a custom.service file in Red Hat Enterprise Linux. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. Let's start by creating and running our own background service using systemd. We'll start by writing a simple script that the service will execute. In the terminal, type the following command to create the script: sudo tee/usr/local/bin/helloservice.sh. Insert a here document operator, denoted by 2 less than signs. Then type eof. This command uses tee and a here document operator to create a new file and allow us to enter multiple lines of script directly into the file. Then press enter. Now type the following line to specify the script's interpreter: #!bin/bash. Then press enter. This line is called a shebang, and it tells the system to use the bash shell to run the script. Next, type this line to print a message into a log file. Echo, open double quotes, then type hello from my custom service at $, inside brackets type date, close double quotes, insert append operator, then type /tmp/hello.log. Here, echo is used to print the message. $ and date inside brackets dynamically adds the current timestamp. Append operator /tmp/hello.log appends the message to a log file located in /tmp. Then press enter. This command outputs a message along with the current date and time into a log file named hello.log, which will be saved in the /tmp directory. Now finish the script by typing eof. eof marks the end of the file. Then press enter. You'll see a confirmation that the script has been created successfully. Next, let's make the script executable. Type chmod +x/usr/local/bin/helloservice.sh. Then press enter. This gives the script the necessary execute permission so systemd can run it. Clear the terminal for a fresh view. Now, let's create a systemd unit file to run a custom script as a service. In the terminal, type the following command: sudo tee/etc/systemd/system/helloservice.service. Insert a here document operator, then type eof. This command uses the here document operator to feed multiple lines into the tee command, which, with sudo, writes the content into a system-level directory. Then press enter. Now type the following lines one by one. Unit inside square brackets. Go to next line by pressing enter, then type description equals my hello service. Press enter. Type service inside square brackets. Next, press enter. Now type exec start with a capital E and S, no space. Then type =/usr/local/bin/helloservice.sh. In the next line, type install inside square brackets. Finally, type wanted by with capital W and B, no space, followed by =multi-user.target. Here's what each section does. Unit section defines metadata about the service. Description adds a short description. Service section specifies how the service should run. Exec start specifies the script to execute. Install section controls how the service is enabled. Wanted by =multi-user.target ensures the service runs at system boot in multi-user mode. Once you've entered all the lines, type EOF, all in capitals. Then press enter. You have now successfully created the systemd unit file for your custom hello service. Let's clear the terminal for a fresh view. Now let's activate and manage our custom systemd service. First, reload the systemd configuration. Type the command systemctl daemon-reload. Then press enter. This command tells systemd to reload all units and re-execute the systemd process. Next, Let's start the service. Type systemctl start hello service. Press enter. This command starts the hello service immediately. To check the logs generated by the service, type journalctl -u hello service. In this command, journalctl displays logs. -u specifies the unit or service, and hello service is the service name. Press enter. You should now see the log output, indicating that hello service has started and later deactivated successfully. To ensure the service starts automatically at system boot, type systemctl enable hello service. Press enter. This will make sure that the hello service starts automatically during the system boot process. And that concludes our demonstration on configuring a custom.service file in Red Hat Enterprise Linux.